Welcome to Unisavior tutorial. In this tutorial, here we need to calculate the maximum force exerted by the other two charges.
Here we have two charges located at A and B. This charge A has the magnitude, that is capital Q, and charge B has magnitude, that is also capital Q. This is capital Q. The distance between these two charges is 2A, and we need to put another charge between these two charges at this would be located at midpoint here midpoint here. So what I do, I can put charges here, and I can put charges here, and I can put the charges here, but that this should be 90 degree to 90 degree, right? Normal. So here I can put also, I can put also here, I can put also here, even though I can put here also, and just below this, just below this line I can put. So I need to get where I need to put all, I need to put this charge, so that I can get the maximum force exerted by charge located at A and B respectively. So what we do, we'll calculate the force, resultant force on this charged particle, and that force is going to differentiate. And here we have a charges, magnitude of these charges are equal, and their distance are equal, but one thing is not everywhere same, the location of this text charge. So this is going to vary, whether it will be here or here, we don't know where it is. So we will going to differentiate this distance. The differentiate, we need to differentiate the force with respect to distance. Okay, here we are going to calculate the maximum distance. So for calculating maximum distance, suppose we have a charge Q that is placed at point A, we have charge Q that is placed at point B. When we combine these together, that distance is 2A. Okay, on this perpendicular distance we are putting here another text charge. Okay, so there is a repulsion, and this force will act like in this way, and there is another force that will be acting from B to C, that will be in this direction, and here we are putting the third charge, that is C. So the resultant will be in this direction. This will be angle theta, so this angle will be equal to this angle. So the component of this force is 2F cos 2F cos theta, because the component of this force and the component of this force will add it together here. So 2F cos theta we are getting. So 2F cos theta, so we have that Fr, that is resultant force, that is equal to 2F cos theta. Now we need to calculate that one. So 2 by 4 pi epsilon naught QQ and divide by A square plus R square, and this is cos theta. Once we are going to calculate this value, 2 pi epsilon naught QQ by A square plus R square, and then we are putting the value of cos theta. This cos theta is equal to base by, this is 90 degree hypotenuse, so this is what, half of this A, so this is A square, and that distance is suppose R, so R square root over or power 1 by 2. So R by, we can say that R square plus 1, that is power is 1 by 2. So this gives us the result 1 by 2 pi epsilon naught q r by a square plus r square and then 3 by 2. So this is overall our result. Now we are going to get the distance for which the force, the resultant force is maximum. So for maximum force, for maximum force we need to do differentiation. So d of r by, with respect to dr. So once we are doing that one, we need to get the result as 0. So we have qq and 2 pi epsilon naught is constant, and we are going to differentiate this amount. So that is what here we need to square, and we'll get 3. Okay, because this will be like that, we are going to differentiation, suppose in such a way that there is a one kind of, say that x by, suppose, dx, and you need to differentiate that one. Suppose you are going to differentiate dy by dx, so that will be what, in this way this will be x square and then x dy by, you are doing dx minus, that is this will be differentiated, and this will be x dx by dx1, and this will be what, y is it as. So like that we are doing this one. So in the same way we are here doing that, and we are getting the value here a square plus r square and then 3 by 2 into 1 minus 3 by 2 into a square plus r square, a square plus r square power 1 by 2 into 2r into r. Okay, so this is right. So next is, we are getting this value, and that value is, equating with a 0. This value, this one is the previous one, is equal to 0. So we have the result is like that, r square a square r square and power 3 by 2, that is equal to 3 by 2 and bracket a square plus r square, and power is 1 by 2 and 2 of r square. This is what next step is, we get a square r square, that is equal to 3r square. So from here we can get the result as, while doing calculation here, a square r square minus 3r square equal to 0, and we have to calculate the value of 2r square, that is equal to minus a square, minus cancel, that is r square is equal to a square by 2, a square by 2. Finally we have a result as, we have result r equal to a by root under 2, r equal to a by root under 2, and the force is radial and away from the center of the circle. The force is, force is the radial here. This force is radial and away from the center of the circle. Okay, so this is, say that we can say that this one is the answer of first question, and this is what the force is radial. The force is radial, the force is radial, and we say that away from the center of the circle. The force is radial and away from the center of the circle. So for calculating this maximum force, we need to differentiate the resultant force with respect to r, and that is equated with the 0. And finally we get the value of r equal to a by r equal to a by 4. So this is the radius where we can get the maximum force. Thank you so much.